A mysterious object, smaller than a British village, older than the sun, just entered our solar system. It's moving too fast to be from here, and the elements inside this alien traveler are the same ones inside you. This is 3IATLAS, and what it reveals could change how we understand life itself. On July 1st, 2025, astronomers detected something extraordinary, an object moving through our solar system that didn't belong here. It wasn't an asteroid from the asteroid belt or a comet from the Oort cloud. Its speed, trajectory, and chemical signature revealed something shocking. This was an interstellar object, a visitor from another star system. Its official name is 3IATLAS, meaning it's the third interstellar object ever discovered by humans. The first was Oumuamua in 2017, a strange cigar-shaped rock that tumbled through space and sparked wild debates about alien probes. The second, 2I Borisov, was more conventional, behaving like a normal comet, but proving that interstellar visitors are real. Now, 3IATLAS has arrived, both familiar and alien at the same time. Discovered by the Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Rio Hurtado, Chile, it first appeared as a faint moving speck of light. But once scientists calculated its orbit, everything changed. It wasn't bound to the sun. Its hyperbolic trajectory means it's just passing through, a true interstellar messenger, never to return. A one-time opportunity to study matter from another solar system, right here in ours. 3IATLAS has a solid nucleus likely less than 1 kilometer wide, about half a mile across, though estimates range from 0.3 to 5.6 kilometers based on Hubble observations. That's tiny compared to its spectacular glow, a coma spanning more than 26,000 kilometers, roughly twice Earth's diameter. It may be small, but it's brighter and more chemically active than anyone expected. Unlike Oumuamua, which reflected little light and lacked a visible tail, Atlas behaves like a comet, a glowing halo of gas and dust trailing behind it. But the surprise is what it's made of. Spectroscopic data revealed that 3IATLAS is unusually rich in carbon monoxide, CO, and carbon dioxide, CO2, while containing far less water ice than any comet we've studied in our solar system. That suggests it formed in a much colder, darker environment, perhaps around a distant red dwarf star, or in the frozen outer edge of another planetary system hundreds of times farther from its star than Earth is from the Sun. Why does that matter? Because 3IATLAS is a cosmic time capsule. The atoms and molecules inside it have been traveling between stars for millions, maybe billions, of years. And some of those molecules are the very same ones that make you: carbon, oxygen, hydrogen, nitrogen, the building blocks of life itself. Every time an interstellar visitor like this passes through our solar system, it brings a new story, one written across light years. It's as if the universe itself dropped off a message, saying, "You're not alone in your chemistry." Now imagine this. The oxygen in your lungs and the carbon in your cells once drifted through the same kind of cosmic dust that formed Atlas. In a very real way, this alien comet is a mirror. It shows us how other worlds work, and reminds us where we came from. Because in the next few minutes, as we explore what's inside 3IATLAS, you will see how a frozen traveler from another star might hold the clues to our own beginnings and the future of life itself. Keep watching. In the next chapter, we'll open this cosmic time capsule and see what 3IATLAS is made of, and how it might connect directly to the origins of life on Earth. Let's look inside this interstellar visitor. When sunlight hits 3IATLAS, it heats up its surface, causing frozen materials to sublimate. That is, turn directly from solid to gas. These jets of vapor create its bright halo. But what those gases contain shocked scientists. Using powerful telescopes like the Very Large Telescope in Chile and the James Webb Space Telescope, astronomers identified molecules that aren't common in local comets. ATLAS releases huge amounts of carbon monoxide and carbon dioxide. In fact, when JWST observed it in early August, 3IATLAS was releasing 129 kilograms of CO2 every second, that's the weight of 2 adult humans, but only 6.6 kilograms of water per second. That imbalance alone makes it one of the strangest comets ever seen. Even compared to 2I Borisov, the only other active interstellar comet we've studied, 3IATLAS stands out. Its CO2 abundance is 16 times higher than what we expect at this distance from the Sun. In other words, it's venting carbon far more aggressively than any comet known, interstellar or local. This unique composition tells us something profound. Not all solar systems build comets the same way. Our own comets are rich in water ice, while Atlas's chemistry suggests it may have formed near the edge of a foreign star system, perhaps 100 times farther from its star than Earth is from the Sun. In other words, it was born in deep freeze. And there's one more surprise. Scientists detected glowing nickel vapor in ultraviolet light, a phenomenon only recently discovered in comets, making 3IATLAS one of the few objects where we've observed this rare emission. This trace of nickel, normally locked deep within solid rock, suggests the object's interior was partially heated by cosmic rays or radioactive decay, releasing metal atoms into space. It's an extraordinary clue about the chemistry of alien star systems. Here's where things connect back to us. Scientists believe that comets like these, whether from our system or others, were the delivery vehicles of life's ingredients. Billions of years ago, when Earth was still molten and dry, icy comets bombarded it, bringing water, carbon compounds, and amino acid precursors. Those early impacts may have literally seeded the chemistry of life. So when we study Atlas, we were not just looking at a frozen rock. We were looking at a potential missing link in the story of our own origin. Its composition helps scientists test whether life's building blocks are universal, whether every solar system might have its own recipe for biology waiting to happen. Because Atlas is actively releasing gases, it lets researchers measure how interstellar materials behave in different environments. We can see how radiation, temperature, and cosmic dust interact, the same processes that shape molecules in our own atmosphere, oceans, and even our bodies. To make it simple, Atlas is like a cosmic lab experiment we didn't have to build. Nature delivered it straight to us. And its message is clear. Life and chemistry are connected across the universe. The atoms that form tea leaves, oceans, clouds, and people are the same atoms drifting through interstellar space right now. Here in the UK, every cup of tea you brew, every breath you take, they were made of the same carbon and oxygen atoms that once drifted between stars. The universe isn't distant. It's in your kettle, in your lungs, in every cell of your body. Keep watching. In the next chapter, we'll bring this story home and connect the dots between this interstellar traveler and your daily life on Earth. Now let's bring this story back down to Earth. Literally. Imagine you're making your morning cup of tea. You pour water into the kettle, heat it, and in minutes you're sipping billions of molecules that once traveled through space. That's not poetic exaggeration. It's scientific fact. The hydrogen in that water was created in the Big Bang, over 13 billion years ago. The oxygen was forged inside dying stars. Every atom in your drink is ancient, some of them older than our planet. Here in the UK, where we drink 100 million cups of tea every day, that's nearly 2 cups for every person in the country, think about that for a moment. Each of those cups contains water molecules that share their atomic heritage with this ancient traveler from beyond the stars. Every cup you brew, every breath you take, they were made of the same carbon and oxygen atoms that once drifted between stars. The universe isn't distant. It's in your kettle, in your lungs, in every cell of your body. 3IATLAS reminds us that this cosmic recycling never stops. Just as comets carried water and organic molecules to the early Earth, interstellar objects like Atlas show that these ingredients are still moving across galaxies. They're part of a galactic circulation system, a constant exchange of matter between stars, planets, and even living beings. And 3IATLAS is proof that this circulation operates on an intergalactic scale. The carbon dioxide it's venting right now, releasing 129 kilograms every second, is the same CO2 you exhale when you breathe. The water molecules it carried for billions of years are chemically identical to the water in your tea. Scientists studying Atlas often use metaphors like molecular archaeology. They're not exaggerating. By measuring the isotopes in the gases it emits, they can trace where and how its materials formed, much like archaeologists analyzing ancient tools. Some isotopes found in Atlas match patterns we see in meteorites on Earth, suggesting that the chemistry of life might follow the same script everywhere. This idea, that life's building blocks are universal, is one of the most powerful discoveries in modern science. And it's deeply human. Because when you realize the same carbon atoms in a comet can also form the cells in your body, you see that we're not separate from the cosmos. We're expressions of it. So the next time you sip your tea, remember, the molecules in your cup may once have floated inside a comet like Atlas, frozen for millions of years, waiting for a warm planet like ours. The connection between space and life isn't abstract. It's physical, chemical, and continuous. That's what makes the study of Atlas so compelling. It's not just astronomy. It's anthropology, chemistry, and philosophy all rolled into one. We're tracing the genealogy of matter and finding that it leads straight to us. Keep watching. In the next and final chapter, we'll explore how the discovery of 3IATLAS is transforming modern science, uniting astronomers around the world and reminding us why curiosity is humanity's greatest superpower. Studying an object like 3IATLAS pushes the limits of our technology, imagination, and curiosity. Scientists around the world are racing to analyze its every photon before it disappears forever into the dark. By early 2026, it will be gone, drifting back into interstellar space. But the data it leaves behind will influence decades of research. Right now, astronomers worldwide are participating in a coordinated observation campaign. The first time humanity has organized such a massive, synchronized effort to study an interstellar visitor in real time. Led by the International Asteroid Warning Network, IAWN, this campaign runs from November 27, 2025 to January 27, 2026, testing our ability to track fast-moving objects with extreme precision. It includes a global workshop, standardized data formats, and regular teleconferences between NASA, ESA, and observatories on 3 continents. From professional facilities in Chile, Hawaii, and Australia to the Hubble, JWST, and even ESA's Mars Express and ExoMars Trace Gas Orbiter, every major telescope is watching. And it's not just professionals. Amateur astronomers across the UK and beyond have joined the effort, many submitting astrometric data through the Minor Planet Center. For a few brief weeks, 3IATLAS has united the entire global astronomy community in a single purpose. Already, new missions are being proposed to intercept future interstellar visitors. NASA's Interstellar probe, currently in concept phase, could one day chase and analyze objects like Atlas directly, capturing samples from another star system before they relost to the void. That is the dream, to physically touch material from beyond our solar system and bring it home. Why is this so important? Because interstellar objects are like control samples for the universe. Each one gives us a snapshot of how other planetary systems form and evolve. If Atlas's chemistry differs from what we see locally, it means there is no single recipe for creating worlds, and that the conditions for life might exist in far more places than we imagine. It also reminds us that space isn't empty. It's alive with motion, matter, and exchange. Every so often, a traveler like Atlas drifts in, carrying whispers from distant suns. And every time we listen, we learn something new, not just about the cosmos, but about ourselves. For scientists, 3IATLAS is a test of collaboration. For everyone else, it's a moment of reflection. The same physics that shaped it shaped you. The same molecules it carries are in your bloodstream. The universe isn't out there. It's in here. That's why studying something less than a kilometer wide, billions of kilometers away, matters. It's not about the rock. It's about curiosity, the invisible force that drives science forward and keeps humanity looking up. So as we close this journey, think about this. The atoms that built your body once drifted in the same kind of cosmic dust as 3IATLAS. Every heartbeat, every breath, every thought, all of it is powered by the same chemistry that began among the stars. If you enjoyed this journey through space and science, give this video a like, share it with a friend who loves astronomy, and subscribe for more. Tomorrow, we'll explore another incredible topic, how space chemistry shapes your everyday life. Because here at Clay Science UK, we make science visual, evidence-based, and beautifully human. One clay molecule at a time.